In this video, we are going to continue working on factoring by the greatest common factor. If you haven't watched part 1 of the video, I recommend going back and looking at factoring by GCF part 1, as well as looking at my video on finding the factors and the greatest common factor of monomials. Those videos are very helpful in understanding where we are starting with this problem. And since it can be a little involved, I'm just going to jump into this process, which is called factoring by grouping. Let's write this on here. Factoring grouping. And this is another way to factor polynomials. It is very useful when we have long polynomials. And the idea here is factor out a greatest common factor by grouping up our terms. So I have taken 12a cubed minus 9a squared, and I've grouped these together. And I'm going to try to find the GCF of just these two terms. And I've also grouped up 20a minus 15, and I'm going to find the GCF of these two terms. Now, unless I want this video to be about a half hour long, I'm not going to show the factorization trees so that we find our GCF that way. I'm going to jump right into what the GCF is, but just know that if you're trying this on your own, you're going to need to figure out what the GCF for this set of numbers, this group is, find the GCF of what this group is, and work from there. So we have our two groups here. Let's get started by finding the GCF of each group. Now, I already know that the greatest common factor for this group is going to be 3a squared. And for the second group, I know the greatest common factor is just going to be 5. So like we saw in part 1, excuse me, what we can do is divide each piece in our group by the GCF. So I'm going to divide 12a cubed by 3a squared, and I'm going to divide negative 9a squared by 3a squared. That gives me 4a minus 3. And I have my GCF on the outside. Now I'm going to do the same thing over here. I'm going to divide everything by the GCF of 5. And I have over here 4a minus 3 with 5, positive 5 on the outside. So hopefully, if you watched part 1 and you've seen the factoring by common binomial factors, we should see something that looks pretty familiar. And if you are able to factor by grouping, you're going to get something like this every time. I have a 4a minus 3 over here, and I have a 4a minus 3 over there. I can use the technique for factoring by a common binomial factor and come up with one parenthesis of 4a minus 3, and the second parenthesis made up of our GCFs, 3a squared plus 5. And there's our answer. Yes, I realize I skipped a little bit since I didn't show how we arrived at what the GCFs are, but hopefully by this point we are starting to get pretty good at finding these GCFs, and we might even know a little shortcut or two so that we don't have to show the factorization trees. But alright, there's our first example. Let's try another. Here's our next example of 9x cubed plus 18x squared plus x plus 2. Once again, we are going to group up the first two terms. I'll put them in parentheses. And we're going to group up the last two terms. I'm going to put those in parentheses as well. We need to find the GCF of our first and our second groups. So why don't you think to yourself, taking a look at these numbers, what do you think the GCF would be? If you said 9x squared, you'd be correct. That is the GCF for this first parentheses. What do you think the GCF for this second set of parentheses is going to be? If you said 1, you'd be correct. So, what we have here is we are going to take that 9x squared and we are going to divide each term in the first group by that. And in the second group, we are going to divide each term by 1. 9x cubed divided by 9x squared becomes x. 18x squared divided by 9x squared becomes 2. So I have 9x squared times x plus 2. In our second grouping, dividing by 1 does not change anything. So I still have x plus 2 in my parentheses, but I need to have my plus 1 outside of it. I still have to include that GCF because I now have x plus 2 as a group and x plus 2 as a group. We get to that same common binomial factor as before. So we finish this off by taking the common binomial factor of x plus 2, take our GCFs, 9x squared plus 1, and there is our answer. We have successfully factored this out. We're going to do one more video. I'm going to hopefully have you do a little bit more of the work and check along with what we see on the video. So let's get to our last example. For the last example here, we have 3x cubed minus 15x squared plus 10 minus 2x. And our goal is going to be to factor this out using grouping. So if you want to pause the video and give it a shot, see how far you can get, or even to all the way to the end, see what happens. Alright, hopefully you gave it an attempt on your own. First thing we want to do is group up the first two terms and group up the second two terms and find our GCF. We need to get the GCF of 3x cubed minus 15x squared. And the GCF here for this first group turns out to be 3x squared. So if I divide both terms by 3x squared, I will get my first set of parentheses of my answer. 3x cubed divided by 3x squared is just x. Negative 15x squared divided by 3x squared is a minus 5. And our GCF goes outside. For our second grouping, our GCF is going to be 2. So I need to divide both pieces by 2. 10 divided by 2 is 5. Negative 2x divided by 2 is negative x. And the 2 goes on the outside. And here, if you've gotten this far on your own, is where you might notice a problem. Okay, what's my problem? When we are factoring by a common binomial factor, our parentheses have to be exactly the same. This is x minus 5, and this is 5 minus x. They are not exactly the same, nor can we just switch the 5 and the x to make them the same. And the reason for that is, think about this. The difference of 4 minus 2 and 2 minus 4. 4 minus 2 is 2. 2 minus 4 is a negative 2. Those are not the same answers. So we have to see if there's anything we can do to turn 5 minus x into x minus 5. And luckily there is. Because, alright, this is a negative x, this is a positive x. This is a negative 5, this is a positive 5. The only difference is that the signs are reversed. So what I can do is I can take out of here a negative 1. I'm going to divide each by a negative 1. That will give me a negative 5 plus x, and that negative 1 is going to multiply against the 2 outside of there. And we're going to have then 3x squared times x minus 5 minus 2 times x minus 5. I just rearranged these. Now I have my common binomial factors of x minus 5's, and we can finish off the problem. Group together the binomial factors of x minus 5 into one parentheses, and then the second set of parentheses is the GCFs of 3x squared minus 2. And there we have it. Factoring by grouping is tricky. It will not always work, unfortunately. You need sort of a special type of problem for factoring by grouping to work. But it is a nice technique when it does work. So hopefully you found some luck with this example and these videos, and good luck with any future problems.